Welcome to another physics class. Today we are going to look at equations of linear motion. And don't forget, if you are new to this channel, don't forget to like, share, and subscribe. So when I post new video, you will be able to get the notification. So, equations of linear motion. There are three major equations of linear motion. Major equations of linear motion. 1. V is equal to U plus or minus AT. 2. S is equal to UT plus or minus half AT square. 3. V square is equal to U square plus or minus 2AS. Well, let me add this one to make it number 4, which is S is equal to V plus U over 2 into bracket T. To make this one that I start as number 4, but majorly we have these three equations. Now, where V is equal to final velocity or speed, U equal to initial velocity, then A, linear acceleration, then T, time taking, where S is equal to total distance. Now, as I said, don't be surprised that I say plus or minus 80. Under this one, the determiner is this A. And don't forget, we have positive A, which is acceleration, and we have negative A, which is deceleration. Now, the next thing is velocity time graph. Velocity time graph of equations of motion. That is, the equation given above, we want to represent them using velocity time graph. Now, we want to represent the equations above using velocity time graph. This is time in seconds. Now, to show the acceleration, that's where there is increase in velocity. Now, that is constant or uniform velocity. When the body comes to rest and it retards like this, we have the velocity time graph like this. But the case of plus or minus now, at this particular area which we have positive A, then our equation will be V is equal to U plus AT. And at this particular area where we have negative A, our equation will be equal to V is equal to U minus AT. That is, what we are saying in essence, On the acceleration side, acceleration plus E. We have V is equal to U plus AT. Number 2 will be equal to S is equal to UT plus half AT square. And number 3 will be equal to V square is equal to U square plus 2AS. Now, on the deceleration side now, deceleration, which is negative A. We have V is equal to U minus AT, S is equal to UT minus half AT square, and V square is equal to U square minus 2AS. That's how it will be. But in the region of this constant speed or constant velocity, don't forget we said at this particular region, A will be equal to 0. And if A is equal to 0 now, then since A is the determinant, the equation 1 for this region will be equal to V will be equal to U. That is, the final velocity at this particular point will be equal to initial velocity when the body decelerates. Equation 2 also will be S will be equal to, since A is equal to 0, all this term will be equal to 0. So we have S is equal to UT. The third equation also will be V square is equal to U square, since A is equal to 0. So under uniform velocity or constant velocity, we are going to have the equation like this: V is equal to U, S is equal to UT, and V square is equal to U square. For the acceleration side, it will be positive. Deceleration side, it will be negative like this. The next thing we are going to look at is how we come across all these equations. Then we are going to restrict ourselves to one side. That's why I say equations of uniformly accelerated body. Here now, we are going to use positive A only. How do we come across all these equations? That is what we want to prove now for equation for uniformly accelerated body now. Let's say you have the velocity time graph like this, velocity in meter per second, and this is time in seconds. 0, 0, an object. Let's say this is the U, the initial velocity, and here is the final velocity. Now, the slope, as we have discussed in our former lesson, the slope of this graph, this is acceleration. So now say from the graph above, from the graph above, slope is equal to A. Don't forget we've talked lengthily on this in our former lesson. And the slope will now be equal to delta V over delta T. And look at it, this is the horizontal where we have time. So, but our delta V is equal to V minus U. So therefore, we can now say that our A is equal to V minus U over T. Then from there now you can now say that V is equal to, V minus U is equal to AT. Therefore, you can now say V is equal to U plus AT. That is equation 1. And don't forget, we define its term, its notation before. That V is what? Final velocity. U is what? Initial velocity. A is what? Linear acceleration. And T is time taken. So this one is the equation 1. Now, don't forget our delta V equal to increase in velocity because we said uniformly accelerated body. Now, let's now move to equation 2. Don't forget equation 2 is S is equal to UT plus half AT square, and S is total distance. Now, to start with, already in one of our discussion we said average speed is equal to total distance over total time taken. At the same time, the same average speed v is equal to v plus u over 2. Our v remain the same, final velocity, u initial velocity. If this one is the take this one as equation 1, take this one as equation 2, Roman figure 2. Now, since this one is average speed and this one is also average speed, equate 1 to 2. Equating 1 to 2, we are going to have S over T is equal to V plus U over 2. Mind you, in equation 2, S is the subject. Now let's make S the subject of this one now. Then we are going to have 2S be equal to V plus U into bracket T. Now our S now will be equal to V plus U over 2 into bracket T. And don't forget, this our V is final velocity, but V equal to final velocity. And final velocity from equation 1 is what? V is equal to U plus AT. Now, here remove V, put the magnitude of V, U plus AT. So you are going to have S is equal to U plus AT plus U into bracket T over 2. U plus U will give us 2U. So you are going to have S is equal to 2U plus AT into bracket T over 2. Open the bracket. So we are going to have S is equal to 2UT plus AT square over 2. So from there, we can now say that S will be equal to UT over 2 plus AT square over 2. That's 2UT. 2UT. So 2 will cancel 2. So we are going to have S is equal to UT plus half AT square. That is equation 2 for uniformly accelerated body. Now, for equation 3, we are going to start the equation 3 also from where we started equation 2 the other time. And equation 3 is V square is equal to U square plus 2AS. Don't forget, we've done this one in the former equation 2. That is, average speed remain the same. Total distance over time taken, and at the same time, V plus U over 2. Then equating, then we arrive at this one. But the other time, you may notice that when we go to this point, we remove this field from equation 1. But at this time now, we are going to remove this t. We now say from equation 1. Equation 1. We say V is equal to U plus AT. Now, we want to remove T from this point. Now, let's make T the subject of the formula. So, we are going to have V minus U is equal to AT. Then, T now will be equal to V minus U over A. Now, this particular point, let's remove T and substitute with the value magnitude of T. So we are going to have S is equal to V plus U into bracket T over 2. So let's remove T now. So we are going to have S will be equal to V plus U over 2 into bracket V minus U over A. Therefore, it will now give us F is equal to V plus U into bracket V minus U over 2A. So, cross multiply, we are going to have 2AS is equal to V plus U into bracket V minus U. So, open the bracket. Now, if you now give us, since V square is the subject of formula, let's take this one to this side and 2AS to the other side. So we are going to have V plus U into bracket V minus U equal to 2AS. Open the bracket now, that will be V into V minus U plus U into V minus U equal to 2AS. That will be V square minus UV plus UV minus U square equal to 2AS. Now, U minus UV plus UV will cancel each other. So we have V square is equal to minus U square is equal to 2AS. Shift that U square to the other side, we are going to have V square is equal to U square plus 2AS. That is equation 3. Now you can now see that the 3 equations I wrote on the board, we prove the 3 equations how we arrive at it, together with the 4th one that I added the other time. If you can still remember, the 4th one that I had is this one. So we come across the 4 equations. So you can now see this equation 1, equation 2, 3, and the last one that I added the other time. Now the next thing is to use all these formula now to solve some problem. Now let's take this one as example 1. Let's start from the elementary examples. A boy walks a total distance of 48 kilometers in 4 hours. Calculate the average speed of the journey. Solution to this one. You know, according to what we've done, average speed V is equal to total distance over time taken. That is, V is equal to S over T. And the question, the total distance S is given as 48 kilometers. Time is given as 4 hours. Now, the average speed now will now be equal to 48 over 4. This one will now give us 12 km/h. Now, you can convert this one to meter per second. If you want to convert kilometer to meter, then it will give us 12 multiplied by 1000, and we have hour. That is over 60 multiplied by 60. That is 1 hour will be equal to 60. 60 minutes is equal to 1 hour. 60 seconds is equal to 60 minutes. So it will be 1 multiplied by 60 multiplied by 60 to convert 1 hour to seconds. So this one will now give us 12,000 divided by 3600, and the answer equal to 3.33 meter per second. That's the answer for this question. Take this one as example 2. A car starts from rest and uniformly increases its velocity until it attains a velocity of 40 meters per second in 5 seconds. Calculate the acceleration of the car. Solution to this one now. We have to calculate acceleration, and as we know, acceleration A is equal to increase in velocity over time taken. Don't forget, A is acceleration, delta V is increase in velocity, and our delta V is equal to V minus U. And from this question now, V is given as 40 meters per second. 40 meters per second. U is equal to 0. Why? The question says the car starts from rest. So U will be equal to 0. And time is 5 seconds. So put all these things. A will be equal to 40 minus 0 over 5. Therefore, it will be equal to 40 over 5. And 40 over 5 will give us 8 meters per second square. That's the acceleration. Now take this one as example 3. The car slows down from velocity of 70 meters per second and comes to rest in 20 seconds. Calculate the deceleration of the car. To calculate the deceleration, don't forget the same symbol as A and the same formula. That is the decrease in velocity over time taken. Here now, this one is decrease in velocity over time taken. Now, don't forget our delta V is V minus U. This one is final velocity. And if you look at this question now, the question is come to rest. So our V here will be equal to 0. U, according to the question, that's 70 meters per second. And time to decelerate is equal to 20 seconds. Put all this one together, our A, which is deceleration, be equal to V minus U over T. Then it will give us 0 minus 70 over 20. This one will now give us A is equal to minus 70 over 20. And the answer is equal to minus 3.5 meters per second square. That is for the deceleration of the car. Now, let's take this one as example 4. A particle starts from rest and moves with a constant acceleration of 0.5 meters per second square. Calculate the time taken by the particle to cover a distance of 25 meters. Here now, let's first write out the parameter given in this question. A is given is 0.5 meter per second square. Again, distance cover S is given as 25 meter. Then we have to calculate time. Now, if you now look at this question, then our equation of motion that is suitable for this, we can first write the three equation or the first equation. V is equal to, since it is acceleration, that will be plus at. Equation 2, s is equal to ut plus half at square. Equation 3, v square is equal to u square plus 2as. And if you like, you can write the additional one. S is equal to v plus u over 2 into t. Let's now analyze and see which one is suitable to solve this question. If you look at equation 1, v is equal to, we are given distance. In equation 1, there is no distance. So equation 1 is not suitable. Look at equation 2. S is equal to ut plus half at square. Distance is there, time is there. Then don't forget, the question says this particle start from rest. So indirectly, u is given. Our u is equal to 0 since the particle start from rest. So we can, if you can use equation 2, it's okay. Let's look at equation 3 if it is suitable. V square minus equal to u square plus 2as. Time is not there, and we have to calculate time. Equation 3 is not suitable. If you look at this equation, the additional one from the question, V is not given. And the question says the particle distance to cover a distance of 25 meters. So this one cannot be used. We are now left with equation 2. So write equation 2 now. S is equal to ut plus half at square. Now, from what is on the board, u is 0. Therefore, 0 multiplied by t will give us 0. So we are now left with s is equal to half at square. So our a is 0.5 and our distance given is 25. So time taken that we have to calculate, that will be t square. So from there now, we can now say this one will be 50 is equal to 0.5 t square. So t square now is equal to 50 over 0.5. And look at this one now. This one will now give us t is equal to square root of 50 over 0.5. Now, 50 divided by 0.5 will give us 100, and root 100 will be equal to 10. So the answer is 10 seconds. It means we use 10 seconds to cover a distance of 25 meters. Let's take this one as example 5. A car accelerates uniformly in a straight line at the rate of 4 meters per second square and covers a distance of 250 meters in 10 seconds. How far will it travel in the next 10 seconds? Now, this question is divided into two parts now. 250 meters in the first 10 seconds, and we have to calculate another distance in the next 10 seconds. Let's first calculate for the first 10 seconds now. Now, let's write out the parameter given. A is given 4 meters per second square. Then distance is given 250 meter. Time is given 10 seconds. The question silenced about the initial velocity. So we need to find u for this vehicle. Now, without wasting our time now, if you write the four equations now, if you look at equation 1, v is there. Inside this one, v is not here. Let's write it as we did the other time. V is equal to u plus at. This one cannot work because v is not given. Let's write the second question. S is equal to ut plus half at squared. Definitely this one will work out. If you write the third one, v squared is equal to u squared plus 2as. This one cannot work it out because we need initial velocity and time is given and time is not there. The additional one, s is equal to v plus u over 2 into bracket t. This one also cannot work it out because of the v. So we have only one equation also, which is s is equal to ut plus half at squared. And from what is on the board, we need to find u. So our s is 250. That will be 250 is equal to u multiplied by 10 plus half multiplied by 4 multiplied by 10 squared. So therefore, we now give us 250 is equal to 10u. That will be 2 here, 2 here. That's 2 multiplied by 100. So this one will now give us 250 is equal to 10u plus 200. Now from this one, 250 minus 200 will be equal to 10u. So this one will give us 50 is equal to 10u. U now equal to 50 over 10. And our u now is equal to 5 meter per second. That's initial velocity that we need. The second part of the question, for the next 10 seconds now. For the next 10 seconds now total time taken, time will be equal to 10 plus 10. That will be equal to 20 seconds. We want to calculate how far now. So use the same formula. S is equal to ut plus half at squared. Mind you, our u is now 20. Our u we calculated is 5. Total time taken is 20. So that one will now give us s now will be equal to 5 multiplied by 20 plus half into uniformly accelerated. The acceleration is the same. So 4 multiplied by 20 squared. So this one will now give us s is equal to 100. This one 2 multiplied by 400, it will give us 800. 100 plus this one, that will be 900 meter. That is for the next 10 seconds. Now, distance cover now. Distance cover. Distance covered in the next 10 seconds will now be equal to the first 10 seconds is, according to the question, is 250. And the one we calculated is 900. That for the next 10 seconds, it will now be equal to 900 minus 250. And this one will now give us 650 meter. That will be the distance covered for the next 10 seconds. Now, let's take this one as example 6. A car moves from rest with uniform acceleration and travel 90 meters in the 5th second. Calculate the velocity of the car 10 seconds after starting. Now to solve this one now. Solution. In the 5th second, let's write out the parameter given. The car is travel at uniform acceleration, but the uniform acceleration is not given. Then distance is given, s is given, 90 meters. But in the 5th second, now, you can now say that the distance traveled in the 5th second will be equal to distance traveled or covered in 5 seconds minus distance traveled in 4 seconds. Let's calculate distance traveled in 5 seconds. Distance traveled in 5 seconds. Under this one now, time is 5 seconds. T is equal to 5 seconds. Now, to use our formula, S, without wasting time, is equal to UT plus half AT squared. Mind you, A is not given. So, the question says the car start from rest. It means if we start from rest, U will be equal to 0. So this term will be equal to 0. We are now left with S is equal to half AT squared. Our time is 5. So that one will now give us S is equal to half into 8 multiplied by 5 squared. So we are going to have is equal to 25A over 2. 25A over 2. That is when it is 5 seconds. The next one, distance travel in the 4 seconds. Using the same formula, S is equal to UT plus half AT squared. Now, don't forget, U is equal to 0. This time will be equal to 0. So the body start from rest. So U will be equal to 0. The body start from rest. So we are now left with S is equal to half AT squared. So this one will now give us half multiplied by A multiplied by 4 squared. So it will now give us, that's 16A over 2. This one will now give us 8A. Now, that is, for the 4 seconds, the distance is 8A. And according to the formula given, distance traveled in 5 seconds minus distance traveled in 4 seconds. The distance traveled in 5 seconds is equal to 25A over 2. That will be minus 8A. And according to the questions, Equation C equal to 90. Now, from this one will now give us 25a minus 16a is equal to 180. Now, 25a minus 16a, that will be 9a is equal to 180. A now is equal to 180 divided by 9, and for A now, it will be equal to 20 meter per second square. 20 meter per second square. But don't forget, the question asks us to calculate velocity. Now, A is known. The question says 10 seconds. Time is known. T also is known. What else do we know? Now, as I said, T is 10 seconds. And according to the question, move from rest. U is equal to 0. Now, to calculate the velocity after 10 seconds, it will now give us V is equal to U plus AT. U is 0, so we are going to have V is equal to AT, which is equal, our A is 20, our time is 10. So that means the velocity now, 20 multiplied by 10 will be 200 meter per second. That is the velocity after starting. Now, this is convenient point to stop for today. In our next video, we are going to continue with this calculation. That is how we can use the equation of linear motion to solve more problems. If time will permit, we combine it with velocity time graph that we've done in our former lesson. And don't forget, as I said earlier, if you are new to this channel, please try to share, like, and subscribe. So by the time I upload a new video, you get the notification in time.